Hello, my name is Baba Wale Olatunji. In this presentation, I'll be going over my predicting the price of used cars data science practicum project. Predicting the price of used cars is a challenging task. This is due to several features that should be examined for accurate prediction. Potential used cars buyers do not know if they are paying too much for the asking price of used cars. Hence, the purpose of this data science practicum project is to develop a machine learning model that will be leveraged in predicting the price of used cars. This project uses Kaggle used car database to achieve its objectives. The data set obtained from Kaggle for this project contains offerings of used cars in Germany. The data set contains over 370,000 used cars information with 20 attributes. It contains some missing values that require data cleaning to increase prediction performance and accuracy. The data set used for this project consists of 14 string variables and 6 numerical variables. The name of each of the 20 variables and their data types can be seen on this slide. The following depicts the first few lines of this data set or from this data set. There are missing values identified as null in the data set. The data also use zeros as missing values. As can be observed from this slide, there are 9 columns with missing values. For example, there are over 40,000 missing values from car engine power column. I dealt with missing values in the data set by dropping the rows and columns that contain them. The result of this is that I now have a clean data set that can now be used for further data analysis, as can be observed from this side of the slide. It is worth noting that missing values will result in distortion, resulting from the difference between missing value and complete data. This data set also contains outliers. Outliers are not missing values. These are values of observation that are distant from other observations in a column. Outliers were identified from relevant columns and removed. It should be noted that outliers will have a positive or a negative effect on the correlation of data if not handled correctly. As part of the data cleaning effort, relevant string columns were converted from strings to categorical variables, and 3 columns were converted from strings to dates. Exploratory data analysis is the next logical step after getting a clean data set. The exploratory data analysis for this practicum project will focus on summary statistics, histograms, and pair plots. More exploratory data analysis can be found in the Python code for this project at GitHub link provided at the end of this presentation. From these summary statistics, we could see that there are now over 240,000 observations for further analysis after completing data cleaning effort. Also, The summary statistics highlight, we can see from here, the summary statistics highlight limousine as the top vehicle and manual as the top transmission type, gas as Golf as the top car car model, and the table below, the second table, highlight the summary statistics for numerical variables in this data set. Here we can see the histogram for each of the numerical attributes. It should be noted that age and month for the cars were actually computed from the month of registration and the year of registration columns. It can be observed that the age and month of most cars in the data set is under 250 months. Most of the car engine powers are less than 500. Car mileage is within the range of 5,000 to 150,000. Here we can see car price and numerical attribute pair plots. Here we can observe the car price and categorical attribute pair plot. Essentially is each of these pair plots, we can see the description of each of the variable and the relationship with the car price. Correlation of data. This correlation map essentially is showing a measure of the linear relationship between each pair of the variables. There is, for example, there is a positive correlation of 0.59 between the car price and the car engine power. That means an increase in car engine will increase the car price. On the other hand, there is a negative correlation of minus 0.47 between the car mileage and the car price. That means an increase in car mileage over time will decrease the car price. Now, splitting data into test and train set. For this project, the data set was split into training data and test data. The training data is the data that the machine learning models will leverage for learning, and the test data is the data used to measure the performance of our machine learning models on test data. Regression and classification are the two types of supervised machine learning algorithms. Predicting the price of a used car is a regression problem. Different types of regression models can be implemented using Python scikit-learn. The scikit-learn is a Python machine learning library. For this practicum project, the training data set will be trained using 4 different regressional models, including linear regression, decision tree regression, random forest regression, and ensemble voting regressor. So the prediction accuracy score for each of the model was generated by providing the test data to the linear regression to each of the 4 models constructed for this project. The prediction accuracy score from each model was used as one of the bases to determine the best model for predicting the price of used car. Linear regression model is the first training model for this project. In linear regression, a model is constructed that enables us to predict the value of new data considering the training data used to train the model. Linear regression model constructed for this project produced a prediction accuracy score of 62% and root mean square error of 4960. It should be noted that a lower value of RMSE metric is preferable. Essentially, this is depicting the scatter plot based on this linear regression model. And the blue straight line is the regression line, or the best fitted line for this linear regression model. Here we can identify a relationship between the predicted car prices and the two car price for this model. Decision tree regression model is the second model constructed for this project. Decision tree trains a model in a tree-like structure to predict data in the future in order to generate a meaningful response or output variable. The prediction accuracy score of this decision tree regression model is 82%. It generates a root mean square error of 3420. Definitely, the result obtained from this model is better than the regression model result. It's better than the linear regression model result. Here we can see the scatter plot for this model. Random forest model is the third model constructed for this project. Random forest is an ensemble technique. It combines multiple decision trees in determining the final output. This model produced a prediction accuracy score of 89%, and it produced a root mean square error of 26.75. That means that this is the best result so far. This model outperforms both linear regression and the decision tree regression models. This is the scatter plot based on this random forest regression model. Assembled voting regression model. This is the final model constructed for this project. It is also an assemble method. For this project, assemble voting regressor essentially fits linear regressor, decision tree regressor, random forest regressor, the three previously developed constructed regression model, each on the training data set. It then averages the individual prediction to form a final prediction. This assemble model produced prediction accuracy score of 86% and a root mean square error of 2985. This model outperforms both the linear regression model and the decision tree regression model. However, this model did not outperform random forest model. Here we can see the scatter plot for this model. So random forest regression model produce the best prediction accuracy out of the four models constructed for this project. Random forest also produce the best RMSE metric for predicting the response or our outcome variable. Hence, random forest regression model is the selected model for predicting the price of used car. This project also highlights car power engine, car mileage, and the age of the car as the three most important features in predicting the price of a used car. Here we can see the project repository. The Python code and the plots for this project is located at this GitHub URL highlighted here, and the project data set can be found at this Kaggle website. Thank you.